Good morning, Prep 3 students. How are you? I hope all of you be fine. Today we'll start to study the first part in our curriculum, which talk about chemical reactions. Our daily life includes many chemical reactions. The first one of them, or the first example of them, burning of fuel in the car engine. Okay. The second one, photosynthesis process, or the chemical reaction which exists in the plant during form their food, like the reaction between carbon dioxide, water, and some mineral salts from the soil to form or to give carbohydrates and oxygen. The third example, medicine, fertilizers, and artificial fibers, and all of these industries depend mainly on the chemical reactions. So let's understand the meaning of chemical reaction. Chemical reaction, it is a process of breaking up the bonds in reactant molecules and the formation of new bonds in product molecules. And we have three main types of chemical reactions. The first type of them, thermal decomposition reactions, which means breaking up of complex molecules or complex compounds to form simpler compounds or to form their original elements. The second type, substitution reactions. Substitution reactions, from its name you can understand some elements replace another elements in its solution. We have two types of substitution reactions. The first one is called single substitution reaction, and the second one double substitution reactions. The third type, oxidation and reduction reactions. And we have two main concepts of this type of reactions. The first concept depends on losing or gaining of hydrogen or oxygen. Okay. The second concept depends on losing or gaining of electrons. Let's start the first type in our lesson, thermal decomposition reactions. The reactions which involve breaking up of the compounds into simple elements or simpler compound by effect of heat. We will study in this part 5 examples. Please concentrate more. The first one, metal oxide. Metal oxide, any metal oxide by heating will divide into metal and oxygen. In our example, mercuric oxide. Mercuric oxide, which has red color, and the colors in these equations very important. Okay, so mercuric oxide, which has red color, by heating will divide into mercury and oxygen gas. Mercury, which has silver color or silver precipitate, and oxygen gas, which increase the flame of match. And this one way to test on the presence of oxygen gas in this reaction. Okay, and now let's show the video of this chemical reaction.
Mercury 2 oxide breaks down or decomposes readily when heated. If we were to weigh the compound before heating and compare its mass to that of the mercury remaining after the reaction, it would seem that decomposition causes a change in the system's mass. The product mercury would weigh less than the reactant. In reality, the decomposition liberates the reactant's oxygen atoms as gaseous dioxygen O2. All matter present before the reaction still exists after it. The reaction obeys the law of conservation of matter.
The second example in our lesson, metal hydroxide. Metal hydroxide, by effect of heat, will divide it into metal oxide and water, and water vapor. And our example in this equation, copper hydroxide. Copper hydroxide, CuOH by 2, which has a blue color. And I said now the colors of these chemical reactions are very important in our curriculum. Okay, copper hydroxide, blue color, give us, or by effect of heat, give us copper oxide, which has black color and water vapor. The third example, or the third chemical equation in this part, metal carbonates. Metal carbonates, by effect of heat, give us metal oxide and carbon dioxide. Metal carbonates in our equation copper carbonates, and the copper carbonates has a green color as we show in this reaction. Green color or copper carbonates by effect of heat it change into black like this. Black color, and the black color represent what? Excellent, represent CuO or copper oxide. And carbon dioxide evolves, which extinguishes the burning match. For the example in this part, metal sulfate. Metal sulfate by effect of heat give us what? Metal oxide and sulfur trioxide. Our example, copper sulfate, CuSO4, and CuSO4 has blue color also, and by effect of heat give us copper oxide, which has black color, and sulfur trioxide, which combine quickly with water vapor producing sulfuric acid. The last example in our lesson, metal nitrates. Metal nitrate like sodium nitrate NaNO3, which has a white color. By effect of heat it changes into or divides into metal nitrites or sodium nitrites. NaNO2 plus O2 evolves, or oxygen gas evolves. The second type of chemical reaction in our lesson, substitution reaction. And substitution reaction, in this reaction the elements which have more activity will substitute the less active elements in its compound. Okay, so we need to remember the meaning of chemical activity series, and it is the arrangement of metals in a descending order according to their chemical activity. Okay, and this is chemical activity series, which starts with potassium and end with platinum. Okay, and we have an important element in this series. This element is called hydrogen, and hydrogen exists in water and exists in all acidic solutions. Okay, and I will tell you about an important knowledge. This knowledge as all elements which precede the hydrogen in chemical activity series can replace hydrogen as solution, or can dissolve in water and they can replace hydrogen in acidic solutions. But all elements which follow hydrogen in chemical activity series can dissolve in water or can't replace hydrogen in acids. Okay, the first type of substitution reaction. Firstly, the meaning of substitution reaction. Let's remember, in this type of reaction, one atom, ion, or group is substituted of another one, and we have two main types. The first type is simple substitution reactions, as we said, and double substitution reactions. Okay, let's start with simple substitution reactions. So simple substitution reactions said one element replace another element in its compound. Okay, like this, and we have many examples of this type of substitution reactions. Firstly, metal substitutes hydrogen in water or acid. The first equation in this part, sodium plus water. Sodium more active than water. Sodium from the most active elements. So sodium will replace hydrogen as solution, okay, or in the water compound, and give us sodium hydroxide, and the hydrogen gas evolves and producing heat. Okay, and the sodium in this chemical reaction can substitute hydrogen of water because sodium is excellent more active than hydrogen. The second example, Cu or copper. Copper is metal plus water. Copper can dissolve in water. Why? Because copper is less active than hydrogen. Okay, the second examples of single substitution reactions, reaction of metals with acids. Okay, and we have three equations in this part. The first equation, zinc plus hydrochloric acid give us what? give us zinc chloride and hydrogen gas evolves. Why? Because zinc is more active than hydrogen. Aluminum plus hydrochloric acid give us aluminum chloride and get rid of hydrogen gas evolves. Why? Excellent, because aluminum is more active than hydrogen or precede hydrogen in the chemical activity series. But in this part we have note is very important to us. Aluminum precede zinc in chemical activity series, so aluminum is more active than zinc in chemical activity series. But aluminum take a long time to replace hydrogen more than zinc. Why? Because aluminum is covered with layer of aluminum oxide. This layer takes a time to separate from aluminum. Okay, the third example or the third equation in this part, copper plus hydrochloric acid, and we just said copper is less active than hydrogen, so there is reaction no, or of course no, there is no reaction. Why? Because copper is less active than hydrogen. Okay, so from the previous examples we can note that the chemical activity of elements, when it increases, the substitution becomes more easier. Okay, the third example, a metal substitutes another metal in its salt solution. Okay, metals can substitute each other according to the difference in chemical activity of all of them. So the first equation in this example, magnesium plus copper sulfate. Magnesium plus copper sulfate. Copper sulfate has a color. What is the color of copper sulfate? Excellent, blue color. Okay, magnesium can replace copper in its solution or its salt solution because magnesium, excellent, precedes copper in the chemical activity series, or magnesium is more active than copper, so it will give magnesium sulfate which has no color, and the precipitation of copper which has reddish brown color. Okay, the second type of substitution reactions is called double substitution reactions, and this reactions occurs between two compounds. Okay, two compounds replacement each other, or the main elements of all of them replacement each other. So in these reactions a double substitution occurs between the ions or radicals of two compounds to give two another or two new compounds. Okay, and we have three main examples of this type. The first example, acid with alkali, which give us salt and water, so this reaction is called the neutralization reaction. Okay, concentrate in this name. The second type, acid with salt. The third type, the reaction between two salts and substitute each other to give us another two salts. Okay, let's start with the first example, acid plus alkali. Acid plus alkali or plus alkali give us salt and water. Okay, and this reaction is called what? Neutralization reaction. So if I ask you about, give reason, the reaction between acid and alkali is called neutralization reaction, your answer is because this reaction give us salt and water. Okay, so our chemical reaction in this part, NaOH base or alkali compound plus HCl acid or hydrochloric acid give us what? Metal will take non-metal and give us salt, and the hydrogen will take the hydroxide atomic group and give us water vapor evaporate by effect or by exposed to heat. The second example, acid with salt. Acid with salt like what? Like sodium carbonate Na2CO3 plus hydrochloric acid 2HCl give us what? Na metal will take non-metal and form salt, NaCl plus H2O and CO2. Okay, the result of this reaction depend on the type of salt and type of acid. The third type in this part, two salt solution. Two salt solutions together, as you see, all of them react together and give us two another salts. Okay, these reactions are combined by the formation of PPT, NaCl, sodium chloride plus AgNO3, silver chloride give us NaNO3, sodium nitrate, and AgCl precipitate with a white color. Okay, the third type in our lesson, oxidation and reduction reactions. And oxidation and reduction are concurrent processes because they occur at the same time. All these reactions occur by two ways. The first way by losing or gaining oxygen or hydrogen, as we said. The second type by losing or gaining electrons. Okay, let's start to study the meaning of oxidation and reaction. By losing and gaining oxygen or hydrogen, the example in our lesson, hydrogen plus copper oxide give us copper and H2O water. Okay, and in this reaction, oxidation process means what? In this reaction, oxidation process means it is a chemical process which causes an increase of oxygen percentage or decrease of hydrogen percentage. So H2 gain oxygen, so H2 changes into H2O or water. Okay, but by losing or gaining electrons, our example, 2Na sodium plus Cl chloride give us sodium chloride. Okay, what is meant by oxidation in this process? It is a chemical process where atom loses electron or more. So what is meant by oxidation? Loses electrons or more, or increase the percentage of oxygen. Okay, so sodium, which represents the neutral atom of sodium, will lose one electron and change into sodium ion or positive ion. Okay, reduction process, it is the opposite of oxidation. So by losing or gaining hydrogen or oxygen, what is meant by reduction? It is a chemical process which causes a decrease of oxygen percentage or increase of hydrogen percentage, and this meaning is the opposite meaning of oxidation. So CuO make reduction. Why? Because it loses one oxygen atom and it changes into Cu or copper. Okay, by losing or gaining electrons, reduction process is the opposite of oxidation process in this concept. So it is a chemical process where the atom gains an electron or more, Okay, so Cl, which represent to one atom or one neutral atom of chlorine, gains one electron and change into negative chlorine ion. Okay, what is meant by oxidizing factor or oxidizing agent and reducing agent? Okay, all of you concentrate more in this part. By losing or gaining oxygen or hydrogen. Oxidation, it is a substance which exists in chemical reaction, okay? Substance or agent which exists in chemical reaction which gives oxygen or takes hydrogen away during the chemical reactions, okay? And reducing agent, substance which takes oxygen away or gives hydrogen during the chemical reaction. So if you remember, oxidizing factor, it is a factor which make reduction, which is CuO or copper oxide. Why? Because copper oxide gives oxygen, okay? But reducing agent represents what? represent hydrogen. Why? Because it takes oxygen. Okay, so the element or the factor which make reduction represents oxidizing factor, and the element or agent which make oxidation represent reducing factor. Okay. By losing and gaining electrons, oxidizing factor, the substance which gain an electron. Okay, so in the previous chemical reaction, chlorine, it is the oxidizing factor. Chlorine which make reduction represent or acts as oxidizing factor. Okay, but what is meant by reducing agent? Reducing agent, substance which loses an electron or more during a chemical reaction. Reducing agent represents sodium in the previous reaction. Why? Because sodium make oxidation. Sodium lose electron or more during a chemical reaction, or lose one electron during chemical reaction. So sodium make oxidation, so it acts as reducing agent. Okay, I hope all of you be understood. Thank you for your listening, and goodbye.